wireless design using 5G wireless design using MATLAB. So if you had a choice having two options, Nokia phones and Apple phones, iPhone, which one would you choose? Right one. What's the difference? Why did you choose it? So, okay, it's all about now you have different technology, different application, enticing applications, and different look, easier, smarter, many capabilities, many features. Even it was really astonishing when they saw Steve Jobs like touching it with his finger, no keypad. And that was amazing. Even when they launched iPhone, it didn't have most of the normal capabilities of a wireless cellular phone. All it had is just the features, and all this was enabled with the capabilities of the software. Why they were stuck here? Okay, because they kept designing from hardware perspective. Hardware, you have limitation. You can mix things, tweak things to up to certain level. Apple tried to do it by hardware, but they failed. Everybody in that direction failed. So the first time ever, Apple was able to squeeze a computer inside your phone and design everything by software. That what gave them an edge over even the experts in mobile industry. So this shows you the importance of softwares in designing amazing applications, devices, technologies, and making them a grand success. Having said this, with the Internet of Things emergence and many other new applications and the blockchain and other artificial intelligence, imagine you want to connect all these things together, all different aspects of life connected with the Internet of Things. Then again, software comes into the picture. You need something very qualified, robust, trusted language that can simulate these cases, give you reliable results, test it, validate it, and based on that, you can launch your product. First by making a prototype and then by the production phase where it's just repetition. To do that, we need set of specification. We call them standard documents that are usually produced by standardization body like 3GPP or IEEE. And these standardization documents, technical people and developers like you and ones working in companies and academia take these documents that were agreed on by the standard body globally, and they try to program them with the hardware, optimize them, validate them, test them so that they can make a product out of them with each and every standard. So once they program it, you have a new product that you can launch and you can start distributing over the whole world. So 4G was launched under the name Release 8 in 2008. And then after that, many releases came after 4G, Release 9, Release 10, 11, 12, 13, 14, and we have now 5G coming in 2020, which was standardized last year. And we have on the other side, we have IEEE wireless LAN, or IEEE standard that basically cares about Wi-Fi, not the wireless, not the cellular part, the Wi-Fi part. Basically develops 802.11a, 11b, G, N, AC. So as you can see, with each technology, with each standard, we have different frequency, different carrier frequency, different data rate, because we have different bandwidth. And after AC, we have AD, AX, AY, AHP. Each one of these technology is dedicated to a certain use case, and most of them, they improve the data rate, by changing and improving the bandwidth and changing the operating frequency. And once you change the operating frequency, then you have different channel characteristics that require different transmitter and receiver design. The same with 5G. But all in all, whatever the technology is, basically most of them, they aim to achieve the following requirements. So when you are designing your new technique or your new technology, your technology should aim to improve one of these requirements. Higher data rates. Does your proposed scheme or algorithm or method improves the data rate? If it does, great. We need this. Industry welcomes this, likes this, would love to buy it from you, to hire you, take it from you. Do you understand me? The second requirement, efficient spectrum use. Spectrum is very scarce, rare, precious, very expensive. You buy it for millions of dollars from the government, and we want to make use of it in an efficient manner. It's not like your car. You bring it to school in the morning and you keep it residing in the park till the end of the day, and again you go and drive it to home. Do you think the use of car is efficient in this manner? No, if you were to use your car efficiently, your car must be running the whole day. But since car is not so expensive and everybody can buy it, and then you can waste the resources. But for a spectrum is so expensive that we cannot allow any wastage of resources in it. When a company like Turkcell buys a spectrum of 2 megahertz to serve the customers, they tell, and during the day people are using the spectrum, using their phones, but at night they are not using it. Why would Turk Telecom, for example, keep using this 2 mega? Why don't you give it to other people who are in need of 2 mega? Here comes your mind, your thinking, your ideas. You say, I have an idea about cognitive radio. The company is allowed to use the spectrum as long as they have customers. Once they don't have customers, they must give it to the users who are using Wi-Fi, because they are congested and the network there is not reliable. So we call this system cognitive radio. Basically, primary user, you must satisfy. If the primary user is not there, is not using his own spectrum, let others make use of it. That's the point. If you are not making use of your land, let others make use of it and they profit the country and they profit the society. If you are not making use of your car, let others use it. If you are not making use of your big home, 5 rooms, 2 kitchens, 3 baths, and you are alone in it, make other use of it. You have lots. Make the point here to use things efficiently, and this is very, very desirable in wireless communication design. If you come up with a technique that in this direction, in this domain. The third one, spatial resources. Not only the time and the frequency, you are limited in time and the frequency. Send your signal from different antennas, from different points, this enhances your reliability and data rate. Low delay and link adaptability. Adapt according to the condition of the channel and reduce the delay of your transmission if you can do this by reducing the complexity. Reliable service everywhere. Wherever you go, you always have connection. If one link is cut, if one link is down, you have other alternative redundant links. High connection density. Internet of Things, where you have massive devices want to communicate with the network doesn't have enough resources to serve them. What would you do? You need to think of new techniques, new algorithms that can help solve these problems. So these are the requirements. We solve them only by bringing new technologies, new algorithms, new transmission schemes. Among these technologies, among examples on these technologies that can help solve these problems, we have massive MIMO. We will talk about it in one of the lectures. We have small cells, heterogeneous networks, new modulation schemes like the MIMO antenna number modulation, OFDM subcarrier power modulation, OFDM index modulation, OFDM subcarrier power modulation, OFDM hybrid modulation, indexing in the space domain, time domain, frequency domain, joined all together to improve and enhance the performance. All these are examples of techniques that can you produce within this semester and shake the ground. Come up with a technology that can help solve some of the critical problems we face in wireless. New frequency bands. People are using now 2 giga, 4, 5, but these are not enough. People are going to 60 giga. Even 60 is not enough. People are going to tera, Wi-Fi, getting internet from light, from the land. And even that is not enough. Now Carlos is thinking of using laser for communication. Yes, bandwidth is so large that it can suffice a large number of users. But what's the problem? Blockage, this and that. If you can address these problems, come up with practical solutions for them, then we can use laser for communication. So while this is all true, we need these things, the requirements and the technology. You as an engineer, you would like to simulate the communication system to see the effect of various parameters, so that you prove that your solution is working, is really, truly improving the performance. You come and tell me, I have an idea. I thought of it last night. I really diligently derived the math, worked out the theory. It makes sense. Everything is fine in it. I liked it. I expect it will improve the bit error rate, or it will improve the data rate. I tell you, okay, fine, thank you. We like ideas, but prove it to us. Everybody will tell you this. How would you prove it? You go to MATLAB, you go to Python, you go to programming, you simulate your system. Tell him, I simulated my system this way, this. This is what how people simulate. And the system without my function, without my method that I introduced, gives this data rate. When I put my method, gives better data rate. You buy it? Yes, I buy it. How much? You determine the price. This is what you have to think about. Clear? So you need to simulate it at the end of the day. Where do you simulate? In MATLAB. That's why you need to know a little bit of MATLAB, because it's a tool that helps you test your ideas, simulate them, get results, and derive. Also, not only this, I don't only want to see the effect of various parameters and quantify how much improvements I get over the existing algorithm, but also it would be good if there are ready-to-use channel models, because I told you, as you change the frequency, the channel model, the characteristics of the medium changes. And to test your signal, to test your transmission and say my transmission is good for millimeter wave, my transmission is good for laser channel, my transmission is good for optical fiber. How would you dare to say these things if you are not testing your system over these channels? So you need channel parameters. Channel parameters are basically kind of mathematical equations that represents the behavior of your medium and the effect of it on your signal when you send it. For example, the modulation scheme that anybody designs, you test it basically first over additive wide Gaussian noise channel. But this is not enough because we have wireless. Then you test it over fading channel. But this is not enough because you have now millimeter wave and fiber optics. Then you go change that model to millimeter wave and test it over millimeter wave. See whether it really keeps working and giving you good advantages and merits or not. Not only this, channel models and see the effect of parameters, but also we want to design antennas like Hijazi, Carlos in the previous courses, they designed antennas that can improve the performance. I want also simultaneously to design the antenna, visualize the parameters, the voltage standing wave ratio, S11, S12, the reflection, the matching, visualize their parameters and test their performance. The radiation pattern. While I do all this, I would also like to connect and test this with hardware. My technique is not only simulation and getting results and theory, but my technique, once I have the code in MATLAB, I can connect it to a hardware device, and it's real life, over the air. You are transmitting your signal. Whatever you designed, just connect it with a hardware device like signal generator or USRB or software defined radio, and your technique is in the air, real life. You tell your customer to whatever, come, it's working, it's practical, it's not only theory. So if you want to do all these together, you need to use MATLAB. So let's study the first point. How to simulate the communication system and detune the parameters. When you come to MATLAB, how does a digital communication system work? You generate your data bits. You are testing now, yes? Everything is simulation, everything under testing phase. You generate your input bits, which are coming usually from video, from image, from text, from speech, whatever. And you use channel coding to protect your data from the impairments of the channel and noise. And then you use modulation to make your signal ready for transmission over the air. And then you use MIMO to transmit your signal from different antennas so that you increase the reliability and the spectral efficiency. And then after that, you use OFDM waveform transmission to limit your signal in time and the frequency, make it robust against interference, reduce the effect of inter-symbol interference, remove the effect of multipath. And after that, you transmit it from the antennas. Can you do all these things in MATLAB, in simulation? You can. After that, you model your channel. Your channel can be noise, additive white Gaussian noise, always, but not always true. It can be also interference coming from other users. It can be small scale fading, multipath, Doppler, the ones we talked about in wireless communication course. It can be large scale fading, path loss, shadowing, blockage. These are the parameters of the channel. You can include all of them. You can test the combined effect of all these parameters together. And then at the receiver side, you have the opposite. You have the antennas, the OFDM receiver, the channel estimation process, MIMO receiver equalizer, demodulation, channel decoding, and you get your bits back. How to do that? By MATLAB simulation. Now for the channel parameters here that you can see in this box, basically you have your base station tower, and this is the mobile user. The distance between the mobile user and base station determines the path loss. How far? More distance, the larger the distance is, the more the path loss. And then there is another base station that's using the same frequency and transmitting. So this mobile phone is getting two signals, one from here, one from here. Of course, this one is stronger because he's closer, but also he receives little bit from this, and this acts as interference. How to test this? You need to consider this into account while you are simulating your system. What are the challenges in designing and evaluating mobile communication? Performance evaluation with realistic channel model. We want this. Realistic, practical. You get them from transceiver system responding to dynamic channel condition. Evaluating the combined effects of fading, interference, nonlinearity of front-end devices, the hardware, phase noise, frequency offset, timing mismatch, IQ imbalance. All these are issues related to hardware. And you need to test. Once you come up with a technique, you cannot say, I tested it over additive white Gaussian noise, it works well, means it works everywhere. No, you need to test it under all these conditions. If it goes to standardization, they will test it. They will consider all these parameters, one by one. Channel estimation and equalization, antenna arrays and directional propagation, beamforming and beam tracking, and many, many, many other things to test, so that they validate and approve your technique. And this is the telemetry, based on the transmit power, mobile range, mobile angle, and modulation order. You get different geometry and you get different scenarios and accordingly different channel characteristics and different radiation patterns. So while you are developing, when you are developing your system, you need to take these into account. Now, what kind of systems we are interested in simulation? We are interested in what's called MIMO-OFDM. Why MIMO-OFDM? Because MIMO-OFDM is used in Wi-Fi, WiMAX, LTE, LTE Advanced, ADSL, the wire. Not only the wireless, the wirelines are using OFDM. The digital video broadcasting for the TV, digital TV, and also not only this, but also in 5G. 5G companies fought with each other for many years, and then they said we will use improved version of OFDM, but the core is OFDM. So when you go to MATLAB and you open the communication systems toolbox, you will find functions. Each function performs certain functionality. Like if you want to modulate using a QAM, you use QAM.general QAM modulator or demodulator, turbo decoder, turbo interleaver, LMS, linear equalization, all these processing that you need for your signal transmission and signal reception are already implemented in MATLAB. They are off the shelf. You just need to call them. Write the function, add additive white Gaussian noise, com.additive white Gaussian noise. These functions are good if you have an algorithm running and you just want to test its performance. But if your contribution, if the technique you are developing is related to modulation, you cannot use this function. You need to use your own function. Clear? Because when you use this function, you don't know what's going on inside the function. You only see the interface. You give input, you see output. But the algorithm, it's hidden from you. That's why you don't learn the algorithm. So, you don't need to learn everything. The one that your contribution has nothing to do with, you just take it as function and use it in your simulation. For example, coding, interleaving, MIMO channel, phase, frequency, offset. You just take it ready. But if my contribution is related to modulator, I cannot use this function. I have to build my own function and use it and see its effect and see whether it works better or bad, worse. You got it? These are ready functions, like when you go to Python, there are functions in any language. You just use them. Baseline, we start with modulation and coding. Start with a size to transceiver with modulation, coding, and scrambling. Simple setup, where you have base station, mobile, interference, source, and this is the distance, theta. This is the signal power you are transmitting, and this is the constellation diagram of your modulated signal. And you can eliminate multipath fading effect and consider simple antenna, isotropic. And you see the performance. This is as first step, like experimenting, learning the setup, learning the functions. And then you start little by little increasing the functionality of your system, add new functions and see the effects on the performance. Use algorithms in communication system toolbox, quickly build and run fast and reliable simulations using these functions. Simulate dynamic changes of system, perform measurement and examine performance metric. As I said, they are nice functions. They can reduce the amount of development. You can test things quickly. But if you want to develop your own thing, you must not use this function. You must write your own function from scratch. Clear? And integrate it within these functions. This is how it works. Let's see the second point, channel models, how MATLAB helps in channel model. There are many ready-to-use channel models in MATLAB. You can use channel models for 802.11 AC, which covers 20, 40, 80, 160 megahertz bandwidth. And it supports 8 spatial streams with MIMO, multi-user MIMO. You have 8 users connected with 8 antennas. And you have also all different types of Wi-Fi, as you can see here, N, A, C, G, A, B, P, J. All these are included in MATLAB in terms of channel modeling. So if you say my technique is good for this channel model, you test it over this channel and see whether it's really performing well or not. Very high throughput, and basically these you can classify them under urban, rural, indoor, outdoor models for communication systems. And they are out of the box, ready mathematical models. You can use them, integrate them with your system very quickly. Basically, they spend, companies and governments and research institutions, they spend usually millions of dollars to get these values and parameters for the channel. Just to get them. Campaign where 100 people work together sometimes. Projects funded by European Union to get the parameters of the channel at certain frequency. So you get them here in MATLAB. These are the results of their research, and you test your signal, your transmission, your method over these channel models to see whether it works. If it works here, it works in practice, because this represents the practice, but in simulation environment. If you want to design antennas, do you need to use a different software like COMSOL, HFSS? You don't need. You can, in MATLAB, do this. You can design antennas, arrays, visualize their parameters, and test their performance. Compute port properties such as impedance, service properties, current and charge distribution, field properties such as near and far field radiation pattern. All these terms, you know about them from electromagnetic course. You can do most of these in MATLAB while you are simulating your system. You can see the effect of antennas on the performance and integrate it with a wireless system. Example on results you can obtain in MATLAB with antennas. You can get the directivity gain of your antenna, the voltage standing wave ratio, the reflection coefficient in dB. These figures are from MATLAB, not from COMSOL. So it means it's powerful. You can use it as well to test your antennas. This is the radiation pattern. This is the impedance of the antenna. And this is the design. You can even draw the design in MATLAB without AutoCAD. So sensor array analyzer, after that you can analyze your antenna parameters. Here are all the parameters, and automatically see the effect of these parameters on the shape. And according to your application, you set the parameters in such a way that you make the radiation pattern in the way you like it. And you just give these parameters to the antenna designer, and once he implements this design, he will get a radiation pattern similar to the one you get in simulation. Not only this, I simulated my system, everything is fine, I get the results, the technique shows performance gains. Now I want to test with hardware. You go to MATLAB and you download the package corresponding to the hardware you have. For example, you have your simulation code that you tested with MATLAB, and it's working and giving result, and everything is fine. I'm showing you how you can take your code to practice real life transmission system. And here something unknown you need to use, which is the package that integrated with the hardware. Hardware is like modem, USB, software defined radio, USRB, spectrum analyzer, or signal generator. These are the hardware that we use to send and transmit our signals. Once you download the package from MATLAB, you can connect your software with the hardware. This hardware, you buy it. Let's see the prices. This is the package where you can install it from MATLAB, and let's see the prices of the hardware you can connect with your code automatically MATLAB and send your signal over the air. You can use this software-defined radio RTL. It's $25. But this is not for transmission, for reception. You receive a signal from the air and analyze it. For example, if you want to see the signal going to certain phone, you just capture it from the air and analyze it, see the signal carrying the bits, carrying the data, carrying your critical information. You can get the critical information from there, because signals are propagating in the air. If you can capture the signal and analyze it, you can get the data back. What's the difference between this that receives your signal and this? The difference is your phone is tuned to receive only over a certain frequency within certain filter and within certain ID. You cannot capture any other signals, but here you capture all the signals on the air. And you can, if you are a hacker and you want to detect the signal and messages over, you can do that as well. If you know the encryption and decrypt it and this. So hackers basically use these tools, software-defined radio, to analyze the signal and get the message out of the air, from the air. You don't have any control. Don't tell me I can protect myself. I know you use encryption to protect, but this encryption, if he knows it, you are gone. All your application, all your data is there to him or her. Can see it, visualize it, get data out of it. Oh, in one of the labs related to wireless in my PhD, we were required in one of the labs, they transmit an encrypted signal over the air using practical wireless device like this one, transmitted over the air, encrypted message, and you are required to record it, capture it wirelessly, real life with devices, and then take it to MATLAB. It's acquisition. You acquire your data and you store it in a vector, very long vector of complex values, numbers and this. From these numbers, from this signal, you get back the message. You decode it, remove the effect of the channel, equalize it, and then get back the message. It's hand-on experience. This is what they do actually if you want to understand how things work, what your phone really does and performs. So basically, you have MATLAB can perform these tasks: data source encoding, channel encoding, digital modulation, up until digital to analog. Up until here we are software. MATLAB can do all these things. That's why we call this simulation. Once you are here, you are hardware. This component performs these. In our courses, in our classes, we don't show you this. We say digital to analog, RF front end, and antenna. Basically, this is the one. And MATLAB is connected with this chip. You have full control over your transmission and reception. Again, you transmit it over the air. You have antenna, RF front end, analog to digital conversion, and then you do the reverse of what you did at the transmitter. If you have modulation, here you have demodulation. If you have encoding, here you have decoding. So basically, you connect your MATLAB with the hardware device and you send your data over the channel. This is at the transmitter side, and your friend has another hardware device that acts as a receiver, and it's connected to MATLAB and start visualizing and receiving your data bits, the ones you transmitted, and see whether they are reliable or not, meeting the requirements or not. So basically, this is, as an engineer, how you can test, how you can move from simulation to hardware implementation and then to industry. Because once you have hardware prototype and your technique is running and giving the performance, after that what you do? Just you give these instructions to company that's specialized in this domain, and they just manufacture the device for you and you start selling it. If you have a good algorithm and you don't want to go to the patent track and sell it for a company, you become a company. So you understand the process, teaching you not only theory but also practice and how to do things in a systematic manner. The supported software-defined radio in MATLAB and RF are the following. We call this RF signal generator. I had it in my previous lab. I used to deal with this. I used it a lot. Sending signal, LTE signal, GSM signals, WCDM, and receiving them and seeing them. The constellation diagram you see in MATLAB, we used to test it in these devices and see them in real life. And then you have the radio, software-defined radio. So if you want to convert your simulation code to hardware product and send it over the air, you must use one of these hardware components or devices. We have in the lab, in the 5G, in the communication lab, we have USRB devices. You can use them as transmitter and as receiver. You just take this device and connect it with the transmitter, one, and MATLAB, and another device for receiver. And you have now a communication link that you can transmit video over it, transmit whatever, messages, speech, video, audio. That's not going through the wireless cellular network. Turk Telecom, Turkcell, you are becoming the network. If you want, you can consider one of these, you can configure one of these USRBs as base station, like the one that Turk Telecom puts on a tower, and serve your friends within a certain area inside the university if they want to talk to each other for free. You can build a network with this, literally. Or you can build a base station and put it inside a UAV, and when an earthquake happens in certain area, you can send that UAV to that area because the base station will be collapsed. And that UAV can serve those customers who are there in that area because they don't have coverage by the original network because the earthquake affects what? The base stations on the ground. There are no base stations on the ground, no connection. How do you solve this problem? You send UAVs carrying USRBs and communicate and serve the customers to talk with each other. So very profound, very, very useful in practical life. Very, very, very useful. If you are interested in these things and you want to participate and become active and develop your own network, your own GSM network, you can join a project called telecominfraproject.com. Telecom Infra Project is an initiative was initiated by Facebook, where the goal is to build white box hardware components for telecommunication equipments. You don't need always to buy things from Ericsson, Huawei, these big companies. You can produce them by your own if you understand things. And you can become the company itself and build your own network. That's secure, nobody touches it. And you know what you did in it. You understand the importance of this and build a network that you can serve your family, your relatives, the important people. I told you one time, if you ever want to be extremely secure, you must use your own devices, your own application, your own network. So that's why this comes into the picture. And nobody can charge you, nobody can tell. Yes, it's your own network. You can allow people to act. It's like building a web application or mobile application. Yes, isn't it? You build a network and let people join you over this network. It's amazing. If you put your heart in it, you can achieve great things in it. So basically, the key takeaways from this, that you can use MATLAB for design and verification, simulate baseband and RF system, including LTE and wireless LAN standards. You can test it over the air by connecting your simulation code with the hardware, and you can prototype and implement. And then after you prototype and implement, you can present to the investor and tell him, look, it's working, it's fine, it's running successfully. I can develop the application so that he can invest in your company or in your idea. because you need a prototype to get the money of the investor. And there are some other resources you can go for them to improve your knowledge on using MATLAB for simulation and hardware testing. With that, we conclude and finish our lecture and meet you next time. Thank you very much for your attention.